Hi, everyone. It's so nice to have you all here. Thank you for taking the time to join us for this very important conversation and the story of restoration. Some housekeeping rules before we start. If you have any questions, please add them to the chat box and we will take them up at the end of the session. Um, with this said, I'll first start with introducing the Ecological Restoration Alliance India. We are an informal alliance of organizations, communities, restoration practitioners, and citizens who are interested in ecological restoration. So anyone can become a member of this alliance as long as there is an interest in restoration. Our aim is to help make ecological restoration a more accessible field by curating knowledge, showcasing projects, and helping build a community and network around ecological restoration across India. We are following an eco-regional approach as it allows us to become more granular with time and help assist and identify unique ecologies within our respective landscapes. For today's talk, we have Dr. Krishna Ray, who's joining us and sharing her experience with ecological restoration of degraded mangroves in the Indian Sundarbans. The Sundarbans are the largest mangrove forests in the world, spanning a total area of 20,480 square kilometers. It occurs in a broad, complex delta region formed by the convergence of two of the largest river systems within India, the Ganges and the Brahmaputra, conjoining to become the Padma. The rivers split and fan out into a dense matrix of channels, creeks, distributaries, and waterways that propel and deposit millions of tons of alluvial clay and silt from the Himalayas and the central Indian highland regions. The mangroves of Sundarban are highly sensitive and vulnerable to the effect of climate change, with the average annual net loss of forests has reached about 5.2 million hectares in the past 10 years. It is here that Dr. Krishna Ray and her team have been working on the ecological restoration of degraded mangrove patches outside the protected areas in the Indian Sundarbans settlement regions. Since 2014, with financial assistance from the Department of Biotechnology, Government of India, and with all logistic supports from the Forest Department from the government of West Bengal. So initially, when Dr. Krishna Ray and her team started, they started by developing a model, which was a site-specific biorestoration technology for an approximate of 3 hectares of degraded patch of mangroves on the banks of Mridanga Banga Valchara confluence at the village of Ramganga. Now in 2023, this small semi-restored patch has shown a lot of improvement. This small, has shown a lot of improvement and harbors almost 30 species of mangroves and associate species, including rare and threatened ones, associated fauna, and in each season, there's an immense natural regeneration of mangrove seedlings, proving the restoration of functionality of the ecosystem as a whole. Once barren, now the site is a biodiverse hub and has been included in the internal website of OECM India as a potential OECM site. I'll give a brief introduction about Dr. Krishna Ray as well. She did her bachelor's and master's both in botany, obtained a Ph.D. from Bose Institute, Kolkata, and did her postdoctoral studies from the Department of Genetics, University of Delhi South Campus. She joined the West Bengal State University, Kolkata as an assistant professor in botany in 2009 and initiated her independent research right from scratch in the area of environmental biotechnology. Her doctoral and postdoctoral research experience in the field of genetic engineering in cotton and mustard made her confident enough to understand the ecological enigma in our environment. and utilize nature's inherent strength to resolve the environmental issues. He assumed ecological restoration endeavor through nature-based solutions in degraded mangroves systems of the Indian Sundarbans since 2014, and continuing till date in a major way with complete financial support, as mentioned before, from the Department of Biotechnology, Government of India. Environmental Biotechnology Group has established a demonstrable comprehensive site-specific biorestoration technology for degraded mangrove ecosystems, irrespective of its location and degradation status. So with this, I would like to, first of all, thank you all for joining in for this talk and to take out time to hear Dr. Krishna Ray and her experience. And I would like to extend a warm welcome to Dr. Krishna Ray and hand it over to her to share her experience in her own words. So welcome, Dr. Krishna Ray.
Thank you, Arjun, and a lot of thanks to your alliance also. I'm very much looking forward to working with you all. Now, it's a great opportunity for me to interact with such a large audience and to tell a story about restoration work at Indian Sundarbans, what we have achieved and what we have not achieved, all these things. And based on that, you can suggest whether how we can improve it and whether it's a theme which we can multiply, you can take forward with all the community's help and with other enthusiasts like Arjun and his alliance and also the similar minded people. So let us see how we can do it.
Thank you, Dr. Krishna. And the alliances, I think it's basically everyone who comes together and pools in knowledge like you are doing. That is what makes the alliance really possible. So thank you so much for sharing this.
So here we are all to know about the ecological restoration of this degraded mangrove ecosystem. So when I started my work, it was long back in 2014. But you see that United Nations, they have already declared this decade 2021 to 2030 as the decade on ecosystem restoration. And everybody knows here that the theme is preventing, halting, and reversing the degradation of ecosystems worldwide. So working on the same theme, we have started our work long back. And just a few facts about ecosystem restoration of degraded ecosystem. These are the few facts I think everybody knows. So whatever strategy we should follow, I believe that they should facilitate secondary succession. We are all striving towards secondary succession while we are working on a degraded ecosystem. So it should be a secondary succession and that should be facilitated. And there should be a comparable co-located reference system, ecosystem. It may be pristine or undisturbed, whatever. So that should be the first point where we are trying to attempt any type of ecological restoration. And with the human intervention, we think that successional period, the secondary successional period, we can reduce it around within 4 to 5 years. Otherwise, it would have been much more. We don't know how much it would take, and we can leave it undisturbed. It might the natural succession will also might occur there, also might initiate there, or might not be initiated also. We have seen several degraded ecosystem there, degraded patches, better I can say degraded patches in Sundarbans that which are left undisturbed for long years, but nothing has happened in that except the Suida and this Sesuvium community. They are trying to expand themselves, nothing else. So with this human assisted restoration, the main component is large scale plantation with seedlings or saplings, whatever. And our final goal should be the fully functional self-sustaining ecosystem, which will be efficient in providing ecosystem services and to some extent, it should support the human livelihoods. So with these few facts, few principles, the ecological restoration program, it should be initiated. There might be some other points also, but these are the things which I understand. These are my views. These are the most important points. And for mangrove ecosystem, if we say, so far, including India, worldwide, it is basically it's a practice of large-scale afforestation, and with one of the best locally available propagule. I know about other areas of Southeast Asia or wherever this type of programs are going on. They are basically choosing these several propagule for this large-scale afforestation. Might be some issues, but not many more. You are doing a large-scale afforestation program, you cannot take too many propagules might be available, but diverse species might not be available. So in case of Bangladesh, there is a report of large area of restoration, and there mostly it is Soneraceae species dominated. So in case of Indian Sundarbans, whatever so far I have found, they are basically with Brugueria, different species of Brugueria gymnorrhiza, not different species, basically with Brugueria gymnorrhiza or Ceriopstegel or different species of Avicennia. These are the main species they utilize for large-scale afforestation. So, and the lower intertidal zone elevations, they are planting them. So these are called basically monogeneric or monospecies plantation. And I don't consider them as ecologically restored mangrove ecosystem. And this is a, you see, this is a typical Brugueria gymnorrhiza plantation in Sundarbans and Indian Sundarbans. And this is almost 18 to 20 years old. You can see it's totally grown up, and just have a look at its understory. This understory is totally devoid of natural regeneration. We have been watching this site since 2014, and since then we have never seen that nothing is coming up. We haven't seen anything coming up at this understory. But natural regeneration should occur. No, I don't know why at these type of afforestation program or plantation program, why natural regeneration is not occurring. Their localization and our sites localization, everything is same, but still nothing is coming up. Hardly, I haven't taken much data about there. Even the epifaunal, these members, they are also quite few at these regions. This is another site. This is by Ceriopstegel. This have been widely planted with Ceriopstegel. Here also the same thing we have observed. So these are all very old plantations, almost 18, 20 years, and we have been seeing them since 2014. So that is also around 7 years we have been seeing them, and they're exactly at the same condition. But you see the basic difference which I have found apart from other things, you see in a pristine ecosystem, these are the natural, this type of natural regeneration is occurring. In every season, I found a large number of propagules are coming up. They might be the most reproductively successful species, or they might be several other diverse species also. But this is the stark difference which I have observed over the last few years. And this monoculture plantation, which people are calling mangrove restoration, it has been highly criticized by this IUCN mangrove specialist group. Since long, they have been criticizing this, and recently they call it as a media effective mass planting. And why they're saying that they have seen that this type of restoration process, it has very low survival rate. And in Philippines and Sri Lanka, it has actually failed, they have seen. And they're saying that this kind of plantation, they are no substitute to pristine actual mangrove, natural mangrove ecosystem. They cannot compensate the biological functions of the loss of mangrove ecosystem. So they are very much against this. So these things keeping in mind, we started working in Sundarbans, Indian Sundarbans, and this ecosystem is considered to be fragile and threatened by everyone knows about the condition of this. I'm just going through a few slides where I can share my experiences, what I have observed over the years. So both the natural stressors and anthropogenic stressors, they're playing hand in hand there, and they're jeopardizing this unique ecosystem. So everybody knows about Amphan. It happened in 2020. This is 2020 and 22nd May it happened, and you can see the date. This is September, and this is the year of COVID also. So there was complete lockdown in West Bengal, but this time it was a partial lockdown. Still nobody was allowed. No, this were allowed at this region at that time. This is a protected region, but fortunately, Forest Department, they allow because we actually forest, but that time miles after miles, this and you can see the main degradation here is due to massive dredging operation. You can see that here the soils are being taken out from these areas, and they are being used for embankment, muddy embankment, earthen embankment construction. This is a very common practice in Indian Sundarbans, because this, where I work, this is the western part of Indian Sundarbans, and there the rivers are too much erosion prone, and embankment is a natural requirement there. Is operational, it's very frequent in Sundarbans at several places, and that causes a major loss of the natural ecosystem there. You can see in all the pictures, I hope it works, this type of, can you see this video?
Yeah, we can see it.
You see how this dredging operation, it operates there. It has been taken on the other side of the river, so otherwise if I'm in front of them, they won't allow me to take the video. So this is how it goes. It will soon clear the whole of the this mangrove patch. So this is the one of the major problem in Indian Sundarbans. And I'm showing you why mangroves are so, I'm not talking about the protected areas. Our protected mangroves are very much well protected, and our government, the forest department is the savior of them. So they are looking after them. I'm just talking about the mangrove ecosystem, which is outside the protected area. And this is a glimpse of that. You see, how is the fringe mangroves there? Can you see this? This is a drone image from the top. This is how dense, you can see how dense is the fringe mangrove, and just beside this, at the back of this fringe mangrove, there is this is the settlement areas, the villages. There's a very narrow gap in between them. So if this mangrove is destroyed, if it is somehow it is totally abolished, then all this saline water that will invade into the agricultural land. This is another one. I want to show this to you also. It's not working. Okay, here you can see this is the mangrove fringes, and just behind it, these are the cultivated lands and the village. So as this part I can skip, that June has already told you that we have started working with a very small area. This is a 3.16 hectare of degraded mangrove patch, and that is also with the fund of Department of Biotechnology, Government of India in 2014. And now the model which we have established there and the technology we have followed there, that is being demonstrated in a large scale manner for about 60 hectares and for several other degraded patches. These are all located at different places, but all within, more or less within the Patharpratima Block in Indian Sundarbans. This is a Patharpratima is a big block in Indian Sundarbans. This is the settlement area there. So there we are trying to see it in a large scale. We are trying to see, and it's a multi-site, and as Arjun has already said, that each site has different types of stressors. So we wanted to show Department of Biotechnology that whether the established technology, it suits different varied type of stressors, and unless and until we can prove that it works for multi-sites and several other having different types of stressors, then it won't be much worthy of applicable, having large applicability. So with that in with that in our mind, we are now demonstrating the same technology. We are just replicating the technology at multi-sites, almost around 30 sites, all the sites comprising about 60 hectares of area. These are all other degraded patches, and there we are trying to use the same technology, but they might have a bit of different type of stressors. Then among each other, they might have varied type of stressors, degradation stressors. It's basically in terms of soil quality. So let us see how it works. I just show you how it is so far, and then you decide whether it is improving or not. Okay, this is the site which has shown much improvement, where we have started our initial work. This is the Google imagery. This is the site. It's named, the village name is Ramganga. So it was like this. Basically at that time, just before that, 2009, there was Ayla, there was another cyclone. And after Ayla, our government has, they have detected that this area, this part is most vulnerable, through which this river water, when the storm, the cyclonic storm occurs, river water can enter into this cultivated area. So they constructed one concrete embankment here at this area, and due to this construction, whatever small mangrove patches were there, it was totally they were removed from that site, and it became more or less a very barren, almost barren looking site. So, and at this 2023, this is the position of that site after we started working. This, after 7 years, it looks like this. And these are the few glimpses when we started our work. You see, this is January 2014 when we started our work. This is the concrete embankment which was constructed at the time, and just standing in front of that, on the top of that embankment, we took the pictures of our site that time. It is at high tide condition. It was like this, and this is in low tide condition. You can see massive dredging had occurred from there, because people have taken out soil from here. So the whole site was almost having very scanty growth of monotypic mangrove species. Mainly Abyssinia was there, or one or two other species, nothing else. So it was almost looking like this. And today, when you can see the date, easily it's July 22. This whole embankment has been well constructed again. And when I stand here, I can see that our mangrove site, it is working as a shield. It's a one kind of protection along with this embankment for the settlement area just behind this. So it looks like this right now. I'm showing you another small video. It's also a drone image. It was taken during this, it is 1 year old. It was taken in January, the beginning of January last year, when we are conducting one workshop there. So at that time it was taken. I'm just first forwarding it. You can see the top view of the area. And in a closer view, you can see it looks like this. I'm fast forwarding it. We have grown here almost 30 species of mangroves and its associates. It's not only mangroves, mangrove associates are also growing here, which are giving a great support to this mangrove ecosystem, although they don't have the conventional adaptation system of the mangroves. I'm just fast forwarding it. You can see. At the same time, you can see that this regeneration is also, several other seedlings also, they're coming up. So how we started? When we started with a large scale grass transplantation. Which are these grasses? There are native 4 halotolerant grasses at Sundarbans, which we identified. Everybody knows about those grasses. One is Patharpratima coarctata, locally it's called as Bani grass. Then another is Myrostachya widiana. Then these two are, Patharpratima is basically lower intertidal. It's ideal for lower intertidal transplantation. And then Myrostachya is a bit lower and middle in between that. This is Myrostachya. And then in middle to upper intertidal phases, the 2 grasses which can flourish very well there, those are Paspalum vaginatum and Sporobolus virginicus. So with these 4 grasses, we started our venture. So at the initial phase, you can see this is the embankment, and this area is totally naked. And we started with grass plantation. This was our first step. And you can ask me from where we got these grasses. They were growing at some other places of the same co-located area. They were growing at some other places. From there, our field staff, they collected them and they have transplanted. And don't think that it's one single attempt at success. You see, we are planting it day after day, and then these grasses are dying. They are not getting adapted. So slowly, we have, after several transplantation, they started getting adapted. This is the condition at January. Then in September, this condition is much better. This is in April. You can see a bit good growth. So it's gradually started. And these grasses were basically keep this, I say that the grasses are the major player. They have actually helped us a lot in establishing this restoration in a proper way. And simultaneously, we started preparing a mangrove nursery. It's very common, everybody does this. So the uniqueness was that we propagated along with the conventional propagules, we started multiplying some of the propagules which are usually not propagated by our forest department. So this is, you can see, this is Phoenix paludosa, this is Xylocarpus meccongensis, Dedis trifoliata, along with Heritiera. This is done by our forest department very frequently. And these are all very old pictures, 2016. And even now, we can see we are following the same practice. We are collecting these propagules from several islands, several places. You see, I have made them geotagged just to show you that there are several different islands, different places from where I have to collect all these propagules. It's not a very easy job. We know after going so many times after that, we have come to know that what is the phenology of that particular, first of all, where the plant will be available. This, you see, this is Brownloia tersa. This is a near-threatened line. Over the last 5-6 years, I couldn't locate where is this, its population, pristine area. Then only after 2020, we could locate this population in a pristine island, in the island, and from there we usually now started collecting. Then we never knew when is its flower coming and when it's the fruits are coming. So for everything we have to get knowledge. To get this knowledge, we have to make extensive travels. And that is the major problem in Indian Sundarbans. The travels are very costly, they're very expensive. So we need to do it regularly. So this is the condition, and this is the transplantation program. We multiply them and then we start them transplanting. This is Insia bijuga. This is also a near threatened line. Only very few populations we could find in Western Indian Sundarbans. I'm talking about the area where I am working. This is the western part of Indian Sundarbans. The eastern part of Indian Sundarbans, which is much more or less it's in confluence with Bangladesh Sundarbans. That is much better. There the soil quality is much better. There the vegetation is much better. But western part is severely degraded. This is Lumnitzeria racemosa. It took a long time for us to find its actual population pristine in the pristine area, and then collecting the seeds and then multiplying them. So at 2020, we were successful largely. So you can see this is Cisalpinia crista. This is a mangrove associate, and it is a legume, basically mangrove legume. These legumes are supplying nitrogen in this nitrogen deficient mangrove ecosystem. So we can find them very much associated with mangroves. So this is the open mangrove nursery, and this is how we started. It is the 2016, this is 2017, then 18, 19, 20, 21. So this is the site of Ramganga. I'm saying that at our data, up to 2018, we have planted. We have done plantation there. After that, we stopped. We didn't plant there. And the survival rate at 2021, mid-2021, we found it's around 62%. But we haven't planted since after 2018. Now, what is happening? It is a self-sustaining process. Every year, a huge number of seedlings are coming up, and the area is getting filled up by its own. So these are the initial stages of grasses while they are growing. This is from a paper from which we published at that time. And what is the advantage of these grasses? These grasses not only prepare the soil, it makes the soil more fertile, because we have checked the rhizosphere of these grasses to be much more fertile than the non-rhizosphere in several terms of nutrients and all these things. And another major thing is that in Indian Sundarbans, the propagules, they are basically dispersed through water and they get trapped. See how much of propagules they are being dispersed with water, and they get easily trapped in the grasses. And you see how much of dense propagules they're coming up. This is from a picture from a new ongoing site, where we can see that this particular advantage, it is a very I say it's the most welcome advantage for us which is doing half of our job. Whenever we are planting the grasses, the propagules which are being dispersed and getting trapped in grasses, they themselves, they're growing in our sites, and they're almost they're covering, they're enriching our sites. So half of our job is done in that way. And this is a new site I'm showing you. Here also, this is the most successful site so far, where we have started working since just 2020 July. And right now, this is the condition. You see there also the grasses are the key player. This is the Spodobolus virginicus. This is Myrostachya. And this is another site, which is also very promising. This is around 13-hectare site. Here you can see this is the site. And not only grasses are growing, in between the grasses, wherever we are getting, we are transplanting this near threatened lines. This is Nipa fruticans, which is very rare there. You see how they're coming up. This is what I said. This is also another near threatened line. This just I mentioned about this one. And this is the Phoenix paludosa. This is also coming up. So not only this, there are several other places also, they are doing very well. And we are measuring the parameters frequently. We are taken some metrics to evaluate the restoration success. A large number of metrics, though some of them I am showing you. You see, this is only for the site Ramganga, for which I am talking about. Here I can show you the major achievement is, you can see initially this is 2014 data on soil, on sand percentage, and you see this is the data on 2021. The sand percentage has gone down so much, but the pristine is the green one. Here you can see. So in several cases, we found that our site is in between the pristine sites and in between and the degraded and pristine intermediate. It is in at intermediate position for several this metrics. These are organic nutrients and texture, but conductivity hasn't changed much. But from last year onwards, we can see that conductivity is also coming down. The sediment conductivity, usually the water conductivity at this area is always above 30 Siemens per meter, because even post monsoon, before monsoon, always sometimes it reaches up to 40 also. But that is the water conductivity. But sediment conductivity also, it was very high initially, 14. In 2021 also there was not much change, but for the last 2 years there have been heavy rainfall there, so it has now come down. It is in 2020, I am not showing you, it is up to 2021 data. So 2022 it has gone down. So therefore it has been easier for us to grow the lower salt loving plants, mangroves, to grow there. So these are the bacterial profile there, you can see. And simultaneously we are taking data on artificial reproduction also. The success of artificial reproduction we are measuring through this several this fruit set percentage. So that is also showing a very great improvement, and it's in between this pristine and data and degraded and sort of intermediate data. Sometimes it's above pristine also, we can see. Okay. So this is how it's going on, but DBH, you cannot find much difference at the DBH of the plants, because these plants are still very young, but there is a great variation there. So we cannot find much difference in the DBH. But I think our major success lies in the self-sustenance process in the what we could introduce in the system. You see, each season a huge number of seedlings, they come up, they are dispersed through water, and they are trapped there and they grow there, and they are increasing day by day. They're increasing the density of the mangrove plantations there. But this is a stark difference with the monotypic plantations, so that you cannot get there. So this is the pristine, and our site is almost mimicking the pristine sites there. So this is I think this is a major achievement for us. And here also, when we took the major seedling data also. Here it is in between the pristine sites and this monotypic sites, for which we at least got some of the seedling regeneration data from them. And these are the different sites where we are multiplying this Sundari Heritiera formis. You can see this is Phoenix paludosa. This is brown Luya tersa. This Lota Sundari, which I was talking about. This is Insia bijuga. This is also a near threatened line. And this is Lumnizeta racemosa. This is also very rare at the settlement areas. So we are successful in multiplying them, and let us see how much there will be the ecological pressure there, and how much they will be able to expand themselves at the site in the longer run. This is Agiolitis rotundifolia. It's globally near threatened, but in Indian Sundarbans, it's not that its condition is not that severe. And these are the different epifauna. I don't know most of their names, so I have just taken the pictures. And this is the, I think this is the major improvement of a size. This is, you see, this is the mangrove horseshoe crab. This has been, in our side, this has started coming from the last year. We haven't seen it earlier, but from 2022, we have started seeing this visiting our site. There are several other this epifauna. Initially, when I started working, I could find only this one and the some of the mud skippers. But telescopium is also there. It was also there, but not many other type of epifauna. I have never visited, I never found there. But now when we have started taking data, we found that this site has become enriched with several types of diversity of epifauna, different types of crabs. This is a tree climbing crab also we can find there. But earlier I never found it. And this is the, this one is the, this is the hermit crab. So different types of hermit crab we can find in this site. And this is the fishes. I do not know most of their name. And the fishing, near shore fishing has started there. We find that sticknet fishing is being operational there, but earlier it was not observable there. And the site has started making beehives also, natural beehives. So seeing that, we have planned to plant their artificial beehives, which will be sponsored by Forest Department. A local self-help group, they have approached us. So as the plants have, they all reached at their reproductive stages. So we are planning that whether since this April, we can plant some of the artificial beehives there to see how much it will be successful. So in this way, we are trying to give some support to the local people. Let us see in the long run what will happen. I'm not sure, because there is the ecological preference will be working. Even if I plant them, how much they will be able to, the different species. I have planted 30 species, but in the long run, I don't know in the long run how many species will be able to survive there and expand there. It depends on the, and in which site, which species will be ecologically preferred by the nature. That is also very much unknown. We can do our job, but ultimately the nature will be the key player to decide which mangrove species will be preferred for that particular site. So depending on all this data, we applied to recently WCM India. So far it is under their internal database, and the physical visit is still pending. They haven't come yet. So let us see. We are very much looking forward to it. And this is a picture where the all different we could gather different experts and ECRs all over India. And actually the UK people were also supposed to come, but due to that Omicron emergency, they couldn't come. So this last year we could organize this workshop. You can see our key attraction was Professor Kathy Rasan. He is the pioneer worker on mangrove, and he interacted with our ECS, and we learned a lot from him. There are several other experts you can see also. So we got a gala time there, interacting with so many experts, so many mangrove enthusiasts there. So I think there lies the success of our so much of striving and all this struggle. And now the time for acknowledgement. This work would not have been possible without this generous financial support, I must say, from the Department of Biotechnology, Government of India. 2014, they visited the Biotechnology Government of India team. They visited our site when it was a completely barren site. This 2023, Dr. Balendra Singh from DBT, he has just visited on 7 January. This is one of our new sites. So, and Professor Bari had been from very beginning of our restoration. Professor Barik was with us. He visited our sites in 2015 also, when it was it was at that time, you can see the grasses have started coming. So that time also he came. And these are the field staff. These are our field staff, which they are getting their salary from Department of Biotechnology project. And they all belong to the local community of Sundarbans. So they know their ecosystem much better than us. So that is my advantage. And these are my old students who from 2014 to 2019, my PhD students who have worked on this ecosystem restoration. They just optimized the process that time. We started seeing the success at that time. And now that success is taking forwarded by these 4 youngsters. They are very enthusiastic. They are my PhD students. They are working closely with this mangrove restoration venture. And our key asset is Choyon. Choyon is from this Sundarban area. He is from Ganga Sagar Island, and he knows the ecosystem like anything. And actually he loves also his own ecosystem, this mangrove. So I think I'm very much looking forward to Choyon, that once he learns all these things, he will be taking this knowledge towards the whole community of that local people. He will spread this knowledge among them and spread the interest among the local community. So I'm very much looking forward to Choyon. Others are also very much enthusiastic. They are all the time, they are at the field and they're working with us. And my major collaborator is my husband, Dr. Sandeep Kumar Basa, and our joint director and Department of Forest, West Bengal. And my university is always helping me on all this support. Thank you for your patient listening.
Thank you, Dr. Krishna Ray. That was really a fantastic journey that you brought us through, and how you started off from even that small degraded patch, 3-hectare patch, and how it has changed over a period of 7 years. It's just been wonderful to see this journey, and I want to thank you so much for sharing that with us. I think I wanted to know, would you have time for questions? Because there are some questions on the chat, and maybe
I have enough time. If people are ready to listen, I'm sorry for delayed presentation.
Okay, so I'll start with I'll just go in the order in which the questions have come. And we'll start with Ayush. Ayush, are you still online, and do you want to unmute yourself and ask your question? Or should we just take it? Right. Okay, so I'll just ask Ayush's question. Ayush had said, is it, if possible, it would be very enlightening to know what amount of funding was required to restore this 3 hectares of mangrove plants. Is this something that you could possibly share with us?
Yeah. It was the fund was around 68 lakhs for 5 years, it was 68 lakhs, but the whole amount was not sent to us. So it's ultimately it reduced to 65 lakhs for these 3 hectares. And initial cost was really high if you take it per hectare cost. But for the next time, for 2020, there is another extension of this project, 2020 to 25. There we have proposed for 60 hectares. And that is also another 5 years. And but here there was major people are required, manpower was required. So the fund is around 2.5 crore for this 60 hectares. And here the 3 students and 8 field staff, they are engaged from this project. So manpower is manpower and travel. These are the 2 major requirements for this type of work actually. So if we are not able to pay our staff, then they won't be working then, no, because it needs constant watching, constant traveling. Traveling is also too much. It needs a lot of money. So these are the major things.
Thank you. I think the next question is from Divya and Sridhar. Do you want to unmute and just take the question?
Yes, Arjun, thanks. Yeah, so this is a question from us. Did you you mentioned in your talk that you went into pristine areas and to look at the species there, and sometimes located rarer plants and so on. But did you have a particular like a benchmark site or a reference area that you used to keep as a sort of a target ecosystem in that region? And how many species of plants are typically found in that benchmark area, particularly the mangrove tree species?
Of course, we since 2014, we took a lot of visits. Even now also, whenever we go to the pristine areas. These are basically in the western part. You have heard about Bhagbatpur, this Prentice, Lothian, then Dhonchi. These are the very close protected areas. These are basically pristine areas. So there we made frequent visits. Even we collect our propagules from there. A lot number of propagules are being collected from those areas also. And there is a small patch, yet there is a small, yet it is undisturbed. This is a very biodiverse beach patch in the settlement area also. And there also we collect a lot of propagules from there also. So I'm not naming that patch at the area because of the safety of that area. It's still not that much anthropogenetically it is intervened. So from there also, so typically it's around 20 to 26, 25 species you can find in pristine areas of mangroves. But as I said, that when we are collecting so many propagules, we are trying to revive all of them. We are trying to propagate, establish all of them at different sites together. We are doing, but it's up to the nature how much it will be favoring the spread of the expansion of which species it will be picked up by that particular site. That I do not know. That is in the longer run. Our job is to plant them and check the survivability, whether it is expanding or not, whatever. But in the longer run, we cannot keep such kind of watches. No, it has to be ultimately it has to be given to the community to look after. So at that time they will be. We do not know in future what will happen. But we have tried to make them as biodiverse as possible with the co-located this reference forest. These are the very close forests where we have been working on. We are basically working on the if you see the western side of Sundarbans, all these protected areas there on the branches of Saptamukhi, this Lothian, Prentice, they are all located on the branches of Saptamukhi river. And these are very close to our site. Our site is very close to Sagar Island also. So
Yeah. Thank you very much, Dr. Ray. And it's a very inspiring presentation. You know, we have been engaged in a small scale restoration work here, along with research, and can really appreciate the amount of work and effort it takes to do something like this, to monitor it properly and document it. So it's really a wonderful presentation and inspiring. I just had one more question, which is that you mentioned the community, and we just wanted to know, are the local villagers part of the process of restoration, and how were there any challenges in trying to engage with them and involve them in restoration or protection of these sites?
Yes, of course. Actually, my failure is I couldn't engage any community. I have depended only on my staff, but actually through them, they belong to the local community. So through them, we used to connect to the community. I have seen, you see, this from this project, this 8 staff, they are very they're getting good salary, and what they have done, they have given subcontract to some local person who is staying close to that site. And when I go for site visit, that local person also come, and in that way the whole community also comes to see, and they are actually protecting, because all this I haven't shown you the maps of our 30 sites which are located. They are located at by road, they won't be far, but they are not connected by road. Unfortunately, they are basically connected by waterways, and they are actually one side from other side is very far enough. So it's not possible for even the 8 persons to look after 30 sites always. So they spend a part of their salary on these local people, and they engage these local people who are just staying beside those sites. And I found them very enthusiastic. They actually protect the sites. So ultimately it has to go through the community. It has to be our basic requirement. It should be to teach the community about the saving, about the conservation of these mangroves. It has to be done actually, because I couldn't do that thing in a bigger way. If anyone is enough I welcome anyone, any organization to come with me and organize different the communications with these community, to teach them that, so that they learn this restoration process, and they take up this duty of conservation, because ultimately in the long run they will be benefited. No, so I have failed in this part because I haven't tried actually, because while I'm busy, you can understand that taking up such big challenge, it needs so much of involvement with research and all field work, all these things. And along with that, I have my university duties also, my teaching my MSc students, PhD students, and all these things.
Yeah.
On my behalf, I couldn't do that. So I am welcome. I'm open to any organization who will be coming and taking up this job for me. That will be an excellent collaboration.
Sure, Dr. Ray. Thank you so much. Thank you very much.
So I'm just going to tying into the answer that you just given. I think Maya had a similar question, which says that given the success of restoration you have done using a more diverse array of propagules than most mangrove nurseries raise, have you been able to influence the practices and the species raised by the Forest Service nurseries or anyone else? So it was kind of tying in, so I decided to take that question first.
Yeah, when we started our work, I found that the forest people, they mainly propagate Sundari, this Heritiera fomes, and other Cyriops, Brugaria, all these things. They usually propagate, and I couldn't find this Rhizophora much in the settlement area. So the forest department is always providing me that Rhizophora propagules, because it grows more or less in the protected areas. So I am not able to get the propagules much from there. So they help me, but I didn't find them multiplying any other species that time. But from last year, I have seen that Forest Department has started propagating this Phoenix paludosa also. This is the mangrove date palm. So that's a good sign. If Forest Department takes up this type of practice and nothing like it. So I think so, because all my reports are being shared with Forest Department because they are my collaborators. So I'm bound to do that. So I hope in the longer run, they will also, because they are also actually, they are also lack of funds. They're running lack of funds, lack of people. So, but I learned a lot from this Forest Department people also. Whenever I go, I even interact with them and I learned a lot from them. So I'm in a bigger way, I'm very much grateful to our Forest Department. They are always open to me. They're always helping me. So I think they will also try to practice whatever I've been doing. I'm sharing all my results with them. So I hope so in the longer run, they also will be taking up this practice.
Thank you. The next question is from somebody from NCF Valparai. Do you want to unmute yourself and take that question? Or should I read it out? Okay, so I'll just read out the question for them. So it was, in the methods that you used for planting, was direct seeding instead of planting saplings an option? And along with that, I think there's another question that ties in, is that what are the species that you said that you planted some associated species? What are the species that you planted as associate species with the mangroves?
Yeah. When we started, initially we knew nothing. So we established the nursery and we tried to collect and propagate them there. When they are a bit established, then we used to transplant them. But gradually over the years, we have learned that there are several species which can grow by direct seeding also. If I just put the propagule directly, put the plant the propagule, it will grow also. So there are several species which grow by in that way. So now we are for them, and maintaining nursery is just a waste of time, waste of money. So we directly, you can seed for those species, you can directly plant them. So we are following that also. And the mangrove associates about which in Sundarbans, the major mangrove associates are, I found a good number of species from Leguminosae family, mangrove legumes, which are I have seen that most of them are producing root nodules. So there must be this rhizobium or this azotobacter, something, this nitrogen fixers, they must be there, symbiotic bacterial association must be there. So these legumes are this dairies, Caesalpinia, Insea, and for this dairies, several species. Then for Caesalpinia also, we have found 2 species. Then this another is there are several mangrove legumes also associated with them, with this mangroves. And this Exicaria agalocha, this is also a mangrove associate. This is associate species, and these grasses are there. And then this brown loia tersa itself, this is a Lata Shundari, this is itself a mangrove associated species. So there are several mangrove associated species which grow along with the mangroves there, and they have we have checked them under scanning electron microscope also, because they are having good phenotypic acclimation. Acanthus illicifolius and all these species, they have good this then this this another thing is, what is that? Volcameria inermis, this is also another species. So these are all mangrove associate species, and they have good phenotypic acclimation process. When they are growing in a higher salt region, we have seen they have their density of salt glands on the surface of the leaves, it is automatically getting increased. But when they are growing in a lower salinity region, their salinity gland density of the glands, they are decreasing. The same way for the different types of hairs, which is presenting in their upper surface or lower surface of the leaves, that is also getting changed, different types of trichomes. So through this type of phenotypic acclimation process, these mangrove associates are able to survive along with mangroves in that hypersaline condition. It's fascinating for them. Really, they're not true mangroves. They're not showing that viviparous germination or this pneumatophore formation, all these things, it's not there. But even after that also, they are surviving. So they have very good phenotypic acclimation process.
Thanks, Dr. Krishna. The next question is from Abhinaya. Abhinaya, would you want to unmute and ask the question directly?
Yeah. Good evening, all. Good evening, Dr. Ray. Thanks for sharing your wonderful experiences with us. So my question was, in restoration projects, what are the methods, or how do we arrive at what would be the appropriate slanting composition for the space? And like, how do we decide on the ratios of species or genus or family when it comes to plantings?
Yeah, you cannot go for any particular composition, a particular percentage of composition, because you never know what will be the survivability rate. So as much as possible, we are transplanting, but the survivability rates, it varies from one to another. For example, I'm saying about the Sundari, this Etiera fomis, for this particular site on which we have applied. There we actually, for the last 2014 to 2018, we have transplanted 6,000 Heritage seedlings there. But when at 2021, we have gone for their survivability. We just found 3 very slender seedlings. They're growing, and their health condition was very unhealthy also. So we actually failed in establishing this Heritidae fomis at the time, because the salinity level was very high. But now for the last 2 years, when the salinity level is going down, we have been able to get some of the Sundari growing there. But rather than that particular site, there are several new sites. They are showing much better growth for establishing Heritidae fomis. So you can never decide upon any fixed composition, fixed percentage. You just actually, most of the seedlings, most of the species, availability of most of the propagules are very rare, very difficult in Indian Sundarbans. So if you take a pristine forest as your reference, for getting those propagules, that is a difficult job. It's really a difficult job. It's not a 1-year job or 2-year job. Over the years, you have to find out where the propagules will be, where you can find them, how you can multiply them, how you can grow them. So it takes a lot of time in establishing that. And in that way, you cannot fix any what I said, that in particular percentage of composition in your target, because you never know how much will survive and how much will be able to expand themselves. Even if they survive, I do not know in the longer run whether it will be able to expand themselves. So I can only choose the species. And the species, the transplantation of species also is following a particular salinity gradient. We measured the salinity of the sites from the reverse side to the inward. And according to its salinity gradient, we choose the species which can be planted there. Because we have already seen over the years that which species loves which salinity. So based on that, we choose the species while planting in a site. Or plantation pattern that also differs from site to site because of the salinity gradient, which is prevailing at that particular site. So we cannot decide pre-decided. We cannot follow a pre-decided percentage of composition, but you can definitely know which species will be working, which species you are targeting to have in your sites. But their survivability and in the longer run, their expansion, you cannot predict. That is what my experience is.
Thank you.
Thank you so much, Dr. Krishna Ray. The next question is by Chandranshu, and he's asking, so Chandranshu is asking, are the close-by farmers aware of the importance of the mangrove ecosystem, and how it helps them with their yields? Also, how do they perceive the restoration process?
They do not understand much about restoration, but what they can see is the tangible thing is that they are getting a forest that's an unhindered, an unbroken mangrove patch just in front of their land, which can give them support, which can protect them from the storm water to invade in the lands. That is what they can understand. So in that way, I always say to the local people, the people who are just staying behind our restoration sites, I only tell them that these mangroves can protect you. Even if your embankment is constructed, they can see that even these concrete embankments within 1 or 2 years that gets broken, that gets heavily damaged. So just within just a attack of one cyclone is enough to destroy that particular concrete embankment, however strong people make it. But if it is protected with another shield of mangrove in front of that, that might be a real protection. That has happened actually in our site. When the embankment was there, in front of this mangrove shield was there, and the area, the cultivated lands and the villages just behind our restoration site, which I'm mentioning, that got protected during Amphan and years for both the cyclones. Those sites got protected. So there was no invasion of storm water, this in hypersaline water. But other sites were breached, other sites which were not maintained, those are breached. So through other sites, their land got affected. So that's the major problem. Nowadays, the cyclone, the technology is so well developed, so people get the news of cyclone much before them. So they are well sheltered, they are well taken to another place. So there is no death or something else, the major harm, but the major harm occurs to their cultivated land and the ponds, the sweetwater ponds where they cultivate their fish, all these things. So those get majorly harmed actually nowadays due to this cyclone, apart from breaking down of the hearts and all these things.
A follow-up to that is, do the villagers support the restoration process if they see the tangible advantages by way of giving their time or any other means?
I think the villagers support it because initially they find us just planting seedlings, and the mangroves being a very slow grower, so it will take a time to make the forest. But for this particular site, which I have been saying that it has been, we are working there since 2014. What happened, if you see my slide, there was a patch there in a 2023, the Google imagery, you can see a clear patch there at the back of the site. What happened in one day in the depth of night, the dredgers, this bulldozer you have seen, it was by a contractor, a scrupulous contractor. He entered in a site and he ran his dredger, and it cleared that area out of mangroves of no reason. He did it. I don't know what was in his mind. And then next morning, when people came to know, they all protested. Not only my staff, all the villagers, they protested. They went to the panchayat, and in that way, that particular contractor was actually punished. So I think they understand. Gradually, they'll be understanding with more and more. This climate change effect will be more visible, more affecting them. I think they will understand the importance of mangroves protecting them, at least, and their livelihood support is also it's becoming understandable. I talked to so many fishermen who were doing this technet fishing around our site. Earlier, this site never had this fishermen. I never saw these fishermen getting fishes here from here. Now they are saying that it is becoming a lovable site by the shore-loving fishes. So they're coming there and they're easily getting them. But I don't know. I cannot. I have not quantified that. How to quantify that? That also I do not know. But I can see that it is slowly it is coming in the livelihood support of the local villagers. The way I'm saying that we are planning to give the artificial beehives to the local villagers through forest department and allowing them to keep that in their side. So I think slowly they will also grow the interest. Initially, nobody understands. They find that why these people are wasting their time over this region. Here, nothing will grow. It's a barren area, something like that. So,
And that is so heartening to hear, like this, the kind of change that happens over a period of time. I think it's very interesting to hear about how, even the community starts changing their perceptions of the kind of work that you're doing. I wanted to check in with you. There are, I think, two more questions. If you have time, then we would love to take them.
I have time. No problem.
Okay, so next I'd like to ask Harsha Bardani if they would want to take their question. Harsha Bardani, would you want to unmute yourself and take the question directly? Okay, so I'll just ask the question for Harsha Bardani. Thank you for your presentation, Dr. Ray. I want to know whether there was any challenge of controlling invasive species in the area, and want to know more about other challenges you faced during restoration and how did you overcome those?
I do not think there is any invasive species in mangrove ecosystem. Hardly, there is nothing in it. I haven't found. And now the Prosopis julifera is invading, but that is only in the upper towards the land area, towards the village area. I've seen Prosopis is invading, but in the mangrove ecosystem, the challenges, the plants actually face so much of challenges. I hardly find any invasive species to grow there. At least I haven't seen Prosopis to invade into our restoration site, but I have seen that Prosopis is invading on the it's in the village side. It is invading that I have noticed, and but it has not yet entered into any of our sites or any of our other mangrove fringe areas. I haven't seen that. So itself, the selection pressure is too high there. So I don't think that invasive species will dare to enter and establish themselves, but I don't know in the long run. And people say dairies is an invasive species there, but I don't consider dairies, species of dairies as invasive species, because they are doing better job in mangrove ecosystem. They're supplying nitrogen. We have checked the nodules for nodules in the dairies roots, so it's fine. Even if they grow along with mangroves, what's the problem in that? That is helping our mangroves to grow. So I don't find there is invasive species problem is so prominent in, at least in the Sundarban ecosystem. And challenges are too many. The whole thing is a challenge. First challenge is getting money, getting fund. Without fund, you can't work. Even after getting fund, your fund is sanctioned, fund will not be released. Even if it is released, it will not reach your university, it will not reach your staff. It's a big problem. So a lot of office work, lot of communications, everything. So that's the major thing. Even if you get funds, then you can, if all these problems are solved, then there are uncertain climate events, which is very frequent in Indian Sundarbans. So it's a very co-sensitive zone, and the climate is very uncertain there. So there are many occasions when we got stuck in the middle of the river, so that we have to heavily depend on the waterways there only. That's the only way. So there are too many challenges. I cannot describe. Once you start working, you will be learning one by one there. And then I think it varies from place to place. In Western Sundarban, it's something like one type. In Eastern type, that will be something else also. It might be. I mean, Western Sundarban in general, the soil quality is very bad. But in eastern side, around the Tiger Reserve region, we found the soil is very fertile, very fertile. I think the restoration work will be much easier to do there rather than in western side. Here, the salinity is high, the soil quality is much not that good, actually.
Thank you. I think there's just one last question from Divya and Sridhar. Do you want to unmute yourself and take it?
Yes, yeah. Just a quick question, because we've heard that Sundari is a very important tree in the Sundarbans, and there are reports of large-scale dieback in the Indian and Bangladesh Sundarbans, crown dieback, and affecting literally thousands to possibly millions of trees. Is that really a very serious issue overall in the Sundarbans now, and also in the area where you're working, Dr. Ray?
Actually, this is also asked to me by my collaborator, this Newcastle University, my collaborator Marian, because people have blown up this issue in such a way. They said that Sundari has this dieback, it's a major problem. Actually, over the so many years we have traveled in so many areas in Indian Sundarbans, but I never have seen this kind of disease happening on Sundari. Whatever we have seen, that the seedlings, they are getting the seedlings at seedling stage, even at the nursery also. I don't know what is the factor. We are trying. Chayan is very much working very hard on this. We said that we think the leaves are getting brown, and eventually those leaves, they get shed, and there is a acute problem in establishment of the seedlings. But the plants which are already mature, which have grown, they are very well, they are reproductively successful, and too many seeds are being produced by them. So we get a lot number of seeds, but the seedling establishment is a major problem in this, at least in western part of Indian Sundarbans. But I have not seen not a single Sundari plant having a dieback crown issue. I haven't seen.
Oh, that's great to know, because
recently we have gone to Bangladesh Sundarbans also, but that's a very short visit. But we haven't found anything like that there. So I don't know why people have made it such an issue, and I wanted to know what is the major cause of that dieback. If it is an infection, there should be, it is a bacteria or fungus, something, there should be something there. I have made a whole research over there, and I never came out with any decision that there is a pathogen responsible for this type of dieback. So I don't know why they're making it a major issue. I find the major issue is the establishment of the Sundari seedlings. It is a major issue for us. Most of the seedlings, they get, even our forest department nursery also, they get brown, the leaves get brown, and ultimately the leaves get shed, and the seedling growth is very much arrested. So that is a major issue for us.
Thank you, Dr. Ray. That's also good to know that, it's not a widespread problem. Possibly it's not a problem at all. And anyway, there are these reports, and I was just curious to know if there is any...
Yeah, Chayan is working very hard on this. Maybe he will be coming up with some new theorem why this Sundari is not getting established. I hope so.
Thank you, Dr. Krishna Ray. I want to just check with everyone in the audience if there are any last questions that they want to ask. If it comes, I mean, if you think of it afterwards, you can always mail me, and I will connect you to Dr. Krishna Ray to answer those questions as well. But just checking in right now, if anyone wants to unmute themselves, ask a question. Otherwise, we can, close the session for today.
I have a quick question.
Yeah.
Yeah, so I wanted to know, like, as you mentioned, that one of the problems is monoculture plantation, which is like, not really doing good or like, any good for the restoration. Similarly, I also heard that doing the plantation on seagrasses is another issue, like maybe not in India and the global level. Do you know about it?
Actually, seagrass transplantation or seagrass restoration, I am not very much aware of that, but that is also a very difficult job. And this seagrass restoration is also a very urgent issue of us. So I think the specialists, they can say about this, but that is also very difficult to restoration. That is also a very interesting ecosystem, which is there. In oceanic mangroves, they go hand by hand, actually very close to each other. But in Sundarbans, it is an estuarine mangrove ecosystem. So there we do not have the seagrasses. But in oceanic ecosystem, I think these seagrasses are an integral part of mangrove ecosystem also. So that restoration part is also very much important. So I do not know, because in estuarine mangroves, we do not find seagrasses in that way. So therefore, I'm not much aware about that.
Okay.
Okay. Thank you everyone for joining in, and thank you for all your patience and for being with us till the end of this conversation. And most of all, I wish there was a way to do an applause, because I really think that is what we need to do. But I would really like to thank Dr. Krishna Ray for sharing her wonderful experience with us and her journey, and with so much energy and enthusiasm with all the questions. So thank you so much for taking the time out for this conversation. And thank you everyone for joining in. It was really nice to have you all. And thank you for your patience with us as well.
I also thank you all for being so long and enduring my delayed presentation, all these things. Thank you so much.